is Chapter 2, Section 6, Ratios and Proportions. Okay, so the first thing we need to talk about are ratios. A ratio is a comparison of two numbers by division. Now, those numbers can represent several things. For example, we can compare the number of restaurants per 1,000 people in an area. We can compare the number of cockroaches per school lunch. There are several comparisons we can make. We can write these comparisons three different ways. X to Y, literally using the word to. We can write it like this, or use it with a fraction bar. A proportion is an equation stating two ratios are equal. So here's an example of a proportion. Now, hopefully you know that 1/2 is equal to 2/4. Now, unless something is glaringly obvious, such as this, the easiest way to test and see if ratios form a proportion, that is, the two ratios are equal, is by using cross products. Remember, products are the answers to multiplication questions, so cross products would be as follows. Now, when we solve, 1 times 4 is 4, 2 times 2 is 4 as well. Notice we get the same value on both sides of the equal sign. By getting the same value on both sides of the equal sign, we've proven that this ratio equals this ratio and that this is a proportion. If we ended up with different numbers on both sides of the equal sign, then these two ratios would not be equal and this would not be a proportion. Let's take a look at another example. Now, fortunately, we're going to get examples where we have variables, so we get to have a little fun. Here we have 10 times 3, and if this truly is a proportion, then that means that 5 times x should equal this. Well, let's see. 10 times 3 is 30. 5 times x is 5x. Divide both sides by 5. X equals 6. Now, with this problem right here, you would get instructions that say, solve the proportion. If necessary, round to the 10th or 100th, something like that. Well, here, we obviously didn't have to do any rounding. But since we knew that this was a proportion going into it, we can use the property of proportions that cross products are equal to solve for x. And we did, so we can put a 6 right in here for x. Let's take a look at a little bit more complicated one. Now, if I tell you that this is a proportion and I want you to solve for x, again, cross products. Here it's pretty interesting because we have 7 times this entire quantity, this difference of x and 2, and here I simply have 4 times 2. I get to use distributive property here. 7 times x is 7x. Right here, that's minus 7 times 2 is 14, and 4 times 2 is 8. Now to solve this, I'm going to add 14 to both sides. That cancels. 7x equals, and 8 plus 14 is going to be 22. To finish this up, I'll divide by 7 on both sides, and in your calculator you would get something like this. Let's say I told you to round this to the nearest 10th place. You would say this is about 3.1. The last thing we have to talk about are scales. Now, scales, these are rates used to make a scale model larger or smaller. Scales are pretty neat. What they do is they take a real measurement, an actual measurement, and they translate that into a measurement on a picture or on a model so that things are accurate. For example, if you wanted to make a realistic model of a housefly, you might have a scale that enlarges something so the model is big enough to actually examine with the naked eye. Alternatively, if you wanted to make a model of maybe a large building, or any building for that matter, so it would fit on your desk and you could examine it, you might want to use a scale that actually shrinks something down. Let's take a look at an example. Okay, so let's take a look at this problem. On a map, a trail is 1 1/8 inch long, and the scale is 3 inches equal 10 miles. What's the actual length of the trail? Now, normally, people put the length that references real life on bottom, or the measurement that references real life on bottom. The truth is you don't have to, as long as you don't mix them up, but I recommend to get in that habit. That way people can read your work easily and know what's what. So, we know that 10 miles in real life is represented by 3 inches on the map. So, you can write actual or real life, whatever you'd like here. And this is going to be our map measurement. And we know that's going to be equal to 1 1/8 inches long on the map and here we're trying to figure out how big that actually is in real life. So we're going to put an X there. So again, our scale is here, map measurement over real life, and this is the measurement of the trail, 1 1/8 inches, and that in real life we don't know what it is. So now that we have our proportion set up, cross products. In the first loop I have 10 times 1 1/8. In this loop I have 3 times x. Now whenever you see a mixed number, turn it into an improper fraction. I'm going to rewrite this as 10 times 8 times 1 is 8, plus 1 it makes 9, 9/8. That's going to equal 3 times x. When I multiply this, 10 times 9 is 90, so we have 90/8 equals 3x. And for those of you who aren't sure how I got from this to that, if I wanted to make this into a fraction, I could by putting it over a denominator of 1. Remember, you can do that to any whole number. Numerator times numerator, denominator times denominator. To remove this 8, I can multiply both sides by it. Here it cancels, and I'm going to work on this side here. I have 90. On this side, 3x's times 8 is going to be 24x. Now I simply divide both sides by 24. And I know that x is going to equal 90 over 24. Now I can reduce this. 24 and 90 are both divisible by 6. 6 goes into 90 15 times, and 6 goes into 24 4 times. So I could say that x equals 15/4, which as a mixed number would be 3 3/4. Now remember, real life, my terms were miles. If it's miles here, that means it's going to be miles here. Just like on my map, inches translated to inches. So this final answer is 3 3/4 miles. So the trail that's 1 1/8 inches long on the map with a scale of 3 inches to 10 miles is going to be about 3 3/4 miles in real life. And if you understand that, you understand everything for this section.